Good.
Good morning. Now we are going to see about the topic queue, right? So queue, what is meant by queue? So queue is nothing but it is a type of a data structure, right? So first we have to know about what is the basic concept of queue. First, it is an algorithm where it is a set of procedure to implement to store the data in the computer, right? So this is one of the way to store the data in the computer, and then that is what the main first point. And then the next point is it is a linear data structure. Linear data structure is nothing but we are going to arrange the data in a linear way. So one below the another you are going to arrange it. So I will show the demo later on, right? The next thing is we have certain operation to perform this linear data structure. So what are the operations we have here? Insertion, insertion of data and deletion of data, and then the last, which is nothing but display of data. So display is nothing but whatever the operation is done in the computer, we have to see whether the data are correctly inserted or deleted correctly, right? So now we'll see about the insertion. So insertion is nothing but the queue structure is nothing. This is the queue structure. So in this queue structure, we have to know the basic part of the queue structure. So we have two pointers to do over the insertion and then deletion operation. So where are the two pointers in this queue? So this is one of the pointer named as rear, which is used for insertion operation. So the next pointer, which is nothing but front, which is used for the deletion operation, right? So now whenever I am going to insert the data, so the rear pointer will be incremented. Whenever I am going to delete the data, the front pointer will be incremented. So for these two operations, we are in need of two pointers to do the operations, right? So now we are going to insert the data 1. So the 1 will be inserted from this. Like how we are going to get a ticket from the counter, right? So we will be moving from the last to the first counter, right? So in the same way, we are going to insert the 1 and then we are going to insert in this way, right? In the same way, I am going to insert 2. So I will be entering in this way. In the same way, I am going to enter 3. So in this way, I will be entering over the data, right? Next, if I want to do the deletion operation, right? So I will be, what I will be doing here is, I will be incrementing over the front. So first I will delete the 1, right? And then the next thing I will be deleting over the 2, and then I will be deleting over the 3. So from this we can say the principle of queue is nothing but first in, first out. So which is entered inside the queue will be the first, and which is deleted from the queue will be the first. Right? So we will be saying the principle of queue is nothing but first in, first out. Right? So now we will see with an example and how we are going to demonstrate with of the queue concept with how we are implementing that in the data structure. Right? So the front pointer will be here. So front pointer denotes the first location, and then rear pointer will be at the last location. Since this queue is of empty, both the pointers will be pointing out the first location, right? So the first location I have said. So how the locations are arranged over? So this data queue data structure is of having two types of implementation. First one is array, and the second one is list. So these are the two ways of representation of queue, right? So now in the array we will be having a separate operation, and then in the list we will be having a separate operation, but both will be having the basic concept of rear and the front pointer, right? So now I am going to, this basically I will be having the initialization of rear and front pointer as -1, right? So when I am going with the queue, for example, the queue size is of 5. So my allocation will be started from 0 to 4. right? So here 0, 1, 2, 3 and then 4. So this is of my Q size, and then initially I will be having the front and the rear pointer as -1. So we can frame the answer in this way, that is whenever the Q is empty, my Q pointer, my rear pointer and the front pointer will be initialized with of -1. So the condition can be when front and rear is of same, right? When the front and the rear is of same, which is of equal to -1, right? So this will be the condition for empty of Q. This will be the condition for empty of Q. So when we are going for the insertion process, right? So I am going to insert 10. So 10 will be inserted, will be travelled throughout in this way, and it will be inserted in the Q here, right? The next one. So when the data are inserted, what will the process? What will be the next process? Rear pointer will be incremented. So rear pointer will be incremented to 0. When I am going to insert the next one, that is 20 as a next data, right? The next, this link will be broken and it will be going to the next field. When I am going to insert the next data, that is known as 30. So when it is entered, this rear pointer will be this will be broken and then this link will be made. So now at this stage, what is the rear value? Rear value will be 3. Sorry, rear value will be 2. Right? So now rear value is 2 and the front pointer is still in the -1. So -1 in the sense, it will be whenever you are going to insert one element, rear and front pointer will be incremented to the first stage. Right? So now this front value will be 0 here. Right? So this is what the insertion operation. When I want to do the deletion operation, what will be the process here? This is my current Q. Rear is of 0, 1, 2. So totally you have here 2. So rear value is of having 2 and front pointer is pointing at 0. Right? So when I am going to do the deletion operation, right? So first I will delete the 10. So when I am going to do the deletion operation, first I am going to do the incrementation of front pointer. After deleting over the data, I will be incrementing the front pointer to the next stage. So now the front pointer is of 1. When I am going to do the next deletion operation, that is second deletion operation, the data will be deleted and the pointer will be moved over to the next stage. So now the front pointer and the rear pointer is of same, right? And then the next, if I want to do the deletion operation, I will be deleting this 30 and the link will be made here. And then here also the deletion operation will be done. So now at this stage, rear also is not having any value and this front pointer also is not pointing any value. So when you delete all the elements, so automatically the rear and front pointer will be default, the value will be -1, which is nothing but we have said that Q is of empty, right? So in this way we can frame over the second point for insertion. So insertion, what can be the condition? So whenever you want to do the insertion operation, you have to check whether the Q is of overflow or not. And then whenever you want to do the deletion operation, you have to check the condition whether the condition is of underflow or not. So what is mean by overflow? Overflow is nothing but we are having over the array size, and if we are going beyond the array size, it is nothing but if you are going above the array size, here it is nothing but overflow condition. If you are going beyond the array size, it is nothing but a deletion operation that will be performed in the deletion operation. So now the insertion operation here, what I said here, the rear pointer will be incremented for the insertion. So if you want to do the deletion operation, you will be incrementing the front pointer. So front pointer by 1. So this is what the basic concept to implement over the queue, right? So this is nothing but deletion. Later on, after performing all the operations, we can check over with the display operations, right? So now I will just give a small demo here. So this is what the queue, this is the nothing but queue data structure, and then now I have some elements here. So in this queue data structure, first this point can be the front, and this point can be the rear. So thus data is coming inside, and then it is now in the front pointer. Then the next data is of inserted. This is of in the front pointer is now 1. And then the next data I am going to insert it, and it will be coming in, and now the rear pointer is of 2. And then now the data is inserted and the rear pointer is of 3. And then the next data is of inserted, now the rear pointer is of 4. So now the rear pointer is pointing here and the front pointer is pointing here. So whenever we are going to delete, this is of the insertion process. So when we are going to do the deletion operation, right? So first I will be removing over the data from the front pointer, and the front pointer is incremented to the 1. So next one, if I want to do the deletion operation, I will be taking over the data here, and now the front pointer is of 2. So in this way I will be performing over the deletion operation. This end is nothing but only the insertion, and this end is nothing but the deletion operation. So finally, after doing the deletion operation, the queue is of now empty. Thank you. Thank you.